The South Pole. Temperatures can drop to more than 75 degrees below 0 Celsius. Snow that falls here never melts. This may just be the most inhospitable spot on the planet. Yet right here, builders are attempting one of the most audacious construction projects ever conceived. A structure like none other. A 21st century research center. A mammoth undertaking. The South Pole Station. The construction site, early morning, and problems are already mounting. A bulldozer won't start. A crane's not working either. Routine mishaps that could happen anywhere in the world. But this isn't just anywhere. It's the middle of Antarctica, where a team of mega builders is taking on the seemingly impossible. In this frozen wasteland, they are constructing a 15,000 square meter high-tech science facility. If the builders succeed, it will be one of the most advanced research centers on Earth. But they are up against staggering odds. Hundreds of workers have to survive the frigid temperatures of the Antarctic. More than 11 million kilos of construction materials must arrive by air. And they can work outdoors for just 110 days per year, during the Antarctic summer. All exterior work must stop for the pitch-black, months-long Antarctic winter. This massive project is the brainchild of the NSF, the U.S. government's National Science Foundation. Planning and construction has been underway for more than a decade. But this is to be the final season to erect the structure. Builders have just over 100 days to complete 3 remaining wings. Then, before the station can be occupied, every element must pass a rigorous inspection and prove it meets all U.S. building and safety codes. A group of NSF inspectors is due in just over 3 months, and the construction team is determined to be ready. If they fail, the new wings can't be occupied, and the station will have to wait till next summer to be completed, putting the project a year or even more behind schedule. For NSF project manager Jerry Marty and the contractor's construction chief Carlton Walker, the pressure is on. At the moment, just one task matters: getting the bulldozer and crane moving pronto. These machines aren't broken, they're frozen. But with a normal Antarctic summer day hovering around 30 degrees below 0 Celsius, this is one problem they've seen before. The stalled crane is a major setback, stopping construction on a job site unlike any other. The altitude is 3,000 meters. The nearest city is almost 1,600 kilometers away. And the steel superstructure is surrounded by over 14 million square kilometers of nothing but ice and snow. So why build here in the first place? For scientists, the answer is obvious. The South Pole's unique environment offers incredible opportunities not found anywhere else on Earth. For astronomers, its pristine atmosphere and location at the Earth's axis makes this the perfect place to gaze into the heavens. For physicists, the permanent ice sheet will allow them to study mysterious subatomic particles that may reveal the very first moments of our universe. Isolated like no other continent on Earth, and with some of the lowest temperatures ever recorded, Antarctica is ideal to investigate man's impact on the climate. But for scientists to work at the South Pole, they'll need to live here. And that will require a unique complex. The South Pole Station will be able to feed and house some 150 people. This new structure will have its own power plant and fuel storage. dining hall. And scattered over more than 3 square kilometers will be utilities and laboratories for some of the most sophisticated science ever carried out. A water treatment plant, a highly advanced climate research center, an enormous mobile drilling rig, and a radio telescope that will search for clues to the origins of the universe. But constructing a vast science complex in this brutal environment takes an unusual breed. For 10-year veteran Carlton Walker, huge challenges are all in a day's work.
We first started talking about this thing in 94, 95. We were drawing it on the back of napkins.
For him and Jerry Marty, it's a year-round job.
We work together off-season, on-season, putting together the planning to make sure that all this steel and all these panels are here on time.
Jerry and Carlton are well aware of the looming deadlines, but the job site is eerily quiet. Without the crane, erecting the steel frame remains at a standstill. But heavy equipment operators have a solution. They bring in a specially designed gas heater to warm up the engine. Though they churn out as much heat as 5 home furnaces, in this extreme cold, they're barely big enough to warm an engine above freezing. And the crane is vital. Without it, no steel is going up today. Finally, some good news. The heaters worked. The engine's running.
Very happy.
The machine is on its way. It seems the project is back on track, back in business. But despite the pace, there's no room for error. The lives of 150 people who will occupy the station, some through the depths of winter, are in the hands of these builders. Once winter envelops the building and its crew, they will be entirely cut off from the outside world. When temperatures drop to 50 degrees below 0 Celsius, planes are unable to land or take off. And when the last plane of the summer leaves, those left behind are truly on their own. It's like leaving a crew on another planet. So everyone working here has to get the job done right, even in the face of terrific obstacles. Including one here that has proven almost insurmountable: snow. On average, it snows just 28 centimeters per year, but that snow never melts. It constantly accumulates, blowing and drifting across the landscape. Tiny crystals that have been the downfall of virtually every structure ever built here, starting with the very first. October 31st, 1956. For the first time ever, an airplane lands at the pole. Within days, 24 Navy Seabees get to work on the first South Pole station. Little more than a rugged outpost, a scattering of small wooden and canvas structures, it succeeds in establishing the first permanent research center. But snow falls and snow drifts slowly but surely swallowed up these tiny structures. So in the late 1960s, plans were laid for an ambitious new project, an enormous aluminum geodesic dome built to accommodate 33 people all summer long and 18 over the winter. The dome became an instant landmark, transforming the pole into a scientific mecca. So successful, it was filled to capacity almost from the day it opened. But it had serious limitations. Despite its huge size, it was no match for the extreme conditions. The only windbreak for hundreds of miles, it held back massive snowdrifts. Clearing snow became a never-ending job. Worse, it was built for 1970s technology and building codes, both now obsolete. Inefficient, outdated, and disappearing into the snowpack, the dome's days were clearly numbered. So architects and scientists had to come up with a radical new plan. A building designed to keep the elements at bay. But the question was, would it work? At the South Pole, snow can swallow almost anything in its path. Even a structure as enormous as this. But designers came up with an ingenious solution. One that had never been tried before in these conditions, or on this scale. They would build a fully modern science station, a veritable research hotel in mid-air. The building will sit atop specially tempered steel columns almost 4 meters high, allowing the snow to pass harmlessly underneath, preventing drifts from building up and burying the station. The walls themselves are angled. Like airplane wings, they will force air passing beneath the station to increase in speed, scouring snow from below. For years, clearing snow with fossil fuel-burning bulldozers has been a nearly continuous task, requiring more than 60,000 liters of fuel per season. But keeping the new station clear of snow will hardly ever require fuel-guzzling heavy equipment, just a steady wind. And the new ideas didn't end there. Even with the wing-like design, planners know that eventually snow will build up. So they incorporated another unique feature. When the snow finally does reach the floor line of the new station, the building can be jacked up a full story, an additional 4 meters. And not just once, but twice. This simple detail will give the new South Pole Station a lifespan of 30 to as many as 45 years. But turning this revolutionary design into a reality will test the mettle of the entire crew.
You don't want me welding over yonder?
Yeah, after you get the scaffold set up.
Building in this environment takes rugged determination.
Let's get fired up, boys! Woo! Come on!
Steel workers suspended high in the air, exposed to the brutal conditions of the Antarctic.
It's like nowhere else on the planet because the temperature gets to you.
Welders working with steel beams that sometimes simply don't fit in the extreme cold. Carpenters who only come inside when it gets too cold for their power tools.
It's a little on the chilly side, I'll tell you that, but the quicker we get things done, the better we stay warm, I'll tell you that.
Cooks, cargo handlers, fuelies, and heavy equipment operators who have the enormous task of keeping supply lines moving.
It's just totally cool to hop in a big rig like this and to move around stuff that, 100 people couldn't move by hand. It's awesome. I love it.
All right, slide it in. Whoa.
Whoa!
With a new summer season just beginning, everyone knows the challenges are tremendous and time is short. 3 new wings of the station need to be completed and pass inspection, all before winter. And with temperatures hovering at 40 degrees below 0 Celsius, conditions are more than just uncomfortable. They make working with steel, already the most difficult job on the site, nearly impossible.
Banging on things with sledgehammers to make them fit, and it's kind of rough, and it's not fine finish work, I can tell you that.
And when a part doesn't fit, a new one absolutely, positively won't get there overnight.
So there's a lot of plan B going on. A lot of cutting and welding, and we'll get a design from the engineers and just have to fabricate it here on site. Whatever it takes to get it all done. We're not going to miss that schedule, is what we've been told, so.
But keeping on schedule is no easy task when you can only stay outside for 90 minutes at a time.
The steel seems to suck the temperature right out of you if you have to sit up there for long times. Stay out here long enough, you get a free Antarctic nose job. Little here, little there. Gone, free of charge.
Frostbite is a constant risk for those who spend their days outside at the pole.
This is an old Alaska snow machiner's trick for avoiding frostbite, and that's duct tape. So you see people with duct tape from their cheeks across their noses all the way across to the other side. Decided to try it, it works great.
Ironworkers here are a tough breed. So tough that they sometimes forget to come in out of the cold. To avoid frostbite, breaks are mandatory.
Break time!
But extreme cold is just one of many obstacles. More than 11 million kilos of material to build the station arrive by air in military Hercules LC-130s. And every item on the job site, from a steel girder to a hammer, makes a more than 19,000-kilometer journey. Just once per year, a freighter leaves Port Hueneme in California and heads for Littleton, New Zealand. Then, an icebreaker clears the channel and the ship steams on to America's largest Antarctic station, the port at McMurdo, before making the final leg by air to the South Pole. Each plane can only carry a maximum payload of about 12 metric tons, so it will take nearly 1,000 flights to complete this mammoth project. And planes can only arrive at the South Pole in the summer, when it's daylight. Winter temperatures are simply too low and will freeze the oil and hydraulic fluids. But even in the summer, conditions are not always ideal. So everyone who works in this airport has to move fast.
When the planes get here, it's time to rock and roll, and that's what we do, we rock and roll. We have a lot of planes coming in today. They'll be coming in about 45 minutes apart with a lot of big, heavy, dumb stuff. You gotta really hustle to get that going.
A small team of cargo handlers and fuelies, workers who offload the fuel that is the lifeline of the station, work 24 hours a day, moving thousands of kilos of material. But the worst part of the job is, they're out on the ground 15 minutes before each plane lands. An eternity in this cold.
When the planes come right after one another, you might be out here for 5 hours straight. Right. You're working hard, but you're not doing a lot of moving around.
South Pole residents, nicknamed Polies, who work outside, have to find creative ways to keep warm. Keeping the body moving is the only way to generate heat. Fortunately, when it gets busy, cargo handlers have one of the most physical jobs at the pole. And without them, work would grind to a halt on job sites scattered over 3 square kilometers, including a massive communication satellite dish that is replacing an old, outdated one. An 11-kilometer-long low-frequency antenna is being strung across the landscape. It will help predict the weather in space, celestial storms that can wipe out our wireless communications. Almost 2 kilometers to the west of the station, construction has begun on what will be the tallest structure at the South Pole, the 10-meter telescope. Its massive mirror will rise 7 stories into the air, and the telescope itself will weigh close to an incredible 275,000 kilograms. But looking through some of the cleanest air on the globe may reveal never-before-seen galaxies and unravel the mystery of dark energy, a force some astronomers theorize will cause the universe to literally rip itself apart. Fortunately, even that theoretical event is billions of years in the future. Still, one project at the pole is bigger than all the others, a project nicknamed IceCube.
Just touching the top of the cable reel.
Scientists have come to the pole to study mysterious subatomic particles called neutrinos. And deep ice is one of the best places to detect them.
Yeah, I can hear you. Want me to start moving again?
Using hot water, a specially designed drilling rig will bore holes nearly 2.5 kilometers down.
We'll go at probably a rate of about 12 meters an hour. So we should be at in 4 to 5 hours at 50 meters.
Close to 5,000 sensors will be lowered deep into ice that froze millions of years ago. Ice that is now clear as glass. 80 holes will be scattered over a square kilometer. So the drilling rig and metal shelter must be transported from location to location. IceCube is a massive undertaking costing $275 million, almost twice as much as the station itself. But the data they will collect may open a window into some of the most perplexing events in our universe's past. exploding stars and gamma ray bursts, even mysterious black holes. This incredible science can only be done at the South Pole, a forbidding place no human had ever set foot until 1911. The first was Norwegian Roald Amundsen. He was followed a month later by British explorer Robert Scott. Now the Amundsen-Scott station bears their names. Yet neither could fathom the scientific powerhouse Jerry Marty and his team are building here today.
Ice cube, first hole, first string deployed, ASTO telescope removed, traverse.
For Jerry, every completed task gets him closer to the finish line.
Not a bad morning today for a Monday. How we doing?
Since the pole was first occupied back in the late 1950s, it has been a rugged place to live and to work. Today is no exception.
This is the NSF rep's office. It's named the Cheese Palace. Carlton had named it after my heritage being from Wisconsin and the years of being a cheesehead.
Let's start.
Jerry heads up a vast operation costing millions of dollars every year, employing hundreds of people worldwide. But his executive suite is little bigger and no fancier than a typical suburban garage. From this rugged outpost, Jerry has watched the new building rise up out of the snow and ice, and he's overseen this job site every step of the way.
Take it apart, move it, put it back together again, right?
As each section of the South Pole Station is completed and cleared for use, it comes online. Finishing this wing was a major milestone. And the new dining hall is now open for business. The South Pole is planning a celebration. A 4-course Thanksgiving dinner for 250 Polies. For the first time ever, cooks at the South Pole are hard at work in a true chef's kitchen.
It's pretty sweet. There's some really nice new toys that they gave us this year. Cheers. Cheers to South Pole.
Like an army, the crew at the South Pole runs on its stomach. Working in extreme cold, the body uses up huge amounts of energy just to stay warm. Workers who spend hours out in the Antarctic cold consume as many as 5,000 calories a day, nearly 3,000 more than needed in a temperate climate.
We don't hold back on the butter, we don't hold back on the rich food. They like it filling, rich, and comforting.
The kitchen crew served a traditional Thanksgiving dinner to 3 separate sittings. It was an event the first explorers here could have never dreamed of.
I wouldn't say this was better than my mother's turkey, but she would probably kill me. So it's almost as good.
Happy Thanksgiving, and you're part of history.
The first Thanksgiving in the new station is a real success. So successful, in fact, that it's easy to forget that most of the building they are in is yet to be built. The station is nowhere near complete, and many of the most challenging tasks lie ahead. The power plant is still supplying much of the old station as well as the new one. Communications are still headquartered in the dome and running on equipment circa 1975. This year will mark the final transition from the dome to the new station. Yet there's still one giant hurdle to overcome: the looming NSF inspection. For the Amundsen-Scott Station, this may be the most important construction season ever. In just a few months, the last 3 wings of this South Pole Research Center must be ready for occupancy. The transition from the old station to the new one is to be completed this summer. The team will be leaving behind the dome, a South Pole landmark for more than 30 years. With its gleaming aluminum exterior, it appears a high-tech wonder. But step inside, and it becomes obvious this structure is little more than a glorified tent. It has little in common with the building that will replace it. The interior is not heated, just a simple shelter from the wind and frigid air outside.
strange to get attached so much to a thing or a place, but without this, sure, there's a new station, and that'll be a great thing. And for science, it's going to be absolutely phenomenal. I mean, the capabilities that we're going to provide they're just so far beyond anything down here, but this was home, and that'll probably be home for the next bunch.
The dome may have had few frills, but it did provide the basics. Living quarters, a library, a communication center, scientific laboratories, a medical center, even a post office, general store, and a pub.
Our only little bar at 90 South. It's got a little bit of character.
But the dome that BK has called home for so long is being dismantled. And as it comes down, the pressure increases to complete the final wings of the new station. A structure built using entirely new techniques, some not even invented when the dome was constructed. In addition to elevating the structure to avoid snow buildup and costly snow removal, the roof, walls, even the floor of the new complex are being built of a special insulated material, greatly reducing energy consumption. Called SIPs, or structural insulated panels, these sheets consist of a heat-stopping foam panel sandwiched between two layers of plywood. To keep you as warm using standard fiberglass insulation, you would need a wall nearly a meter thick. At the pole, conserving energy is paramount. Delivering a liter of fuel here costs almost $7. But life at the South Pole means total reliance on energy and technology. And the most important technology is the heating and electric plant. Lighting the new station will be the most sophisticated power plant ever designed for these extreme conditions. It's able to squeeze every ounce of energy out of the fuel it consumes. 3 electric generators run off of diesel engines, generating nearly 1,000 kilowatt hours of electricity. But these engines are designed to do more than just power the generators. Like the heating in your car, excess heat created by the engines is recovered and piped throughout the station. Using glycol, a form of antifreeze, a radiator system supplies 80% of the heat used in the station. Supplemental furnaces are rarely needed, except on the coldest of winter days.
The whole station down here at South Pole is heated primarily off of the one generator that's running. We scavenge every bit of heat that we possibly can.
The heating plant is up and running. But much remains to be done, and deadlines are drawing ever nearer.
Well, that's a tight fit.
Constructing the exterior of the station is not even half the job. Work crews spend even longer building out the interior, installing electrical wiring, running plumbing throughout the entire station. HVAC systems with nearly 2,000 meters of ductwork will move warm air throughout the new building. More than 10,000 drywall panels will be going up. More than 100 kilometers of communication lines will snake through the walls. Construction is happening all over the job site, and all of it managed by Carlton Walker and his team of foremen.
So that means this week is, like I said, cryo, Tyvek.
To keep the project on track and on schedule, they kick off most days with a morning meeting. Today, they're starting right on time, at 4 a.m.
Did you guys get the plugins moved?
Carlton is keenly aware that he can't just bring in new workers when things fall behind, so he must regularly adjust his priorities.
If everything else goes to the side, we move comms today, top of the list.
Despite 15 years at the pole, Carlton has never forgotten the risks of working in an environment like this.
There's no timeline or deadline that's worth getting hurt about, so that is the single thing to stress today. Let's go build some stuff.
And his years on the job have not made things any easier either.
Every year's a battle. It's just a different battle. It's weather, it's flights, it's material, it's everything. Every year is different. If it was easy, I wouldn't be here.
In just 6 short years, these mega builders have built almost 6,000 square meters of interior space. Both major sections are now enclosed, 8 wings in all. And each of those 8 wings have required 113,000 kilograms of steel, 250 SIP panels, and 21,900 worker hours, all spent out in temperatures that average 30 degrees below 0 Celsius. But with just 55 days left in the season, huge tasks remain. Finishing the station is just one of them. The 10-meter telescope, soon to be the tallest structure ever built at the pole, is rising fast. One of the most powerful telescopes ever built, it will capture images of the heavens unattainable anywhere else on the planet. Located at the axis of the Earth, it will always be aimed at the southern sky, unaffected by the rotation of the globe. Most importantly, Antarctica has some of the driest and cleanest air on Earth, giving an unparalleled view of the cosmos. Every season, hundreds of flights ferry construction materials, food, supplies, and workers from the American base at McMurdo to the South Pole. But once a year, one plane carries a different kind of payload. A group of passengers called simply the design team. But despite their innocuous name, they come for one reason, and one reason only: to inspect every detail of every job done on the Amundsen Scott station. And they'll stay for 7 days.
Welcome back.
7 full days that have been dubbed Hell Week.
The pleasantries are over. This is the week that we truly don't sleep. There's anxiety, there's tension, there's some stress levels that are definitely visible here this week.
There's always pressure, there's always, you know, what they want to see, what's done, on and on and on.
Jerry and the team know what they're up against. Every occupied portion of the station has been through this drill already, but never on this scale. This is the final season. If they fail, 3 wings, nearly 40% of the building, will sit empty throughout the upcoming winter, delaying the project by a year, costing millions in overruns. The inspectors fan out. Working round the clock, they look for fire and safety violations, electrical code compliance, structural integrity, mechanical problems, even aesthetic issues.
Flat part is supposed to be turned around.
They'll go through it with a fine-tooth comb. They'll look at every single item on the drawings.
During Hell Week, every morning kicks off with a meeting. The design team faces off with the construction team and delivers the punch list, a daily list of deficiencies to be corrected.
Well, as of compiling this document, 75 total items on the list today broken out.
Issues are divided into priority 1, 2, and 3. But it's the priority 1s, items that could threaten the very life safety of the crew, that must be addressed immediately. And conditional occupancy of the station cannot happen without the approval of one person, NSF Facilities Manager Sandy Singer.
I'm responsible for all decision-making leading up to and granting conditional and final occupancy of government facilities in Antarctica. We have a big job ahead of us.
The design team has barely unpacked their bags, but they've already begun to spook the construction team.
Right now is that the plans call for a stairwell to be out there. No question.
They've uncovered a major deficiency, one that's taken the builders completely by surprise.
What you just told me indicates that a ramp is not an acceptable form of egress. Is that correct?
It has to meet the same handrail requirements as a stair.
To move supplies into one wing, the team built a temporary snow ramp, just meant to last the winter. But inspectors don't see that as sufficient. Conditional occupancy requires a stairwell at every fire exit. This item is just the beginning. The fire alarm is not working properly. There are serious issues with the installation of the steel beams beneath the station.
Instead of pipe perfectly enough for them to put the bolts in, it chose to weld instead.
And a railing is not up to code.
I don't believe there's any power to this one. The unit heaters down here, did you know any reason why they'd be turned off?
Yeah, one of the issues, I think, is just energy.
No. We'll add it to the list.
Mark it up, though.
Even electrical and mechanical systems are turning up huge issues. And the cycle continues.
Lots of issues?
And basically called
The teams meet. Punch lists are presented. Tensions rise.
Gotta work on quality.
No
You
question.
just gotta do it. And not only that, but the architectural finishes this time have dropped, so we haven't really seen a gain.
Hell Week is clearly taking its toll. Carlton and his team are pushing as hard as they can. But there are no A's for effort here. There are some 40 items on today's punch list. A number that could be called normal, even low for a major construction site anywhere else in the world. But this is the South Pole. And Sandy Singer knows the lives of 150 people are at stake. If an emergency arises here in midwinter, help could literally be months away.
Obviously, we're running out of time. We've got about 3 days left. Friday is the day that we want to get conditional occupancy. And we've got about, I'd say, 40 priority 1 items that are still outstanding.
This inspection is even more stressful than the team feared. It's going down to the wire. And the situation is about to get worse.
7 o'clock. Let's go around the table, have the design team develop the priority 1 issues.
I guess this is kind of the big one. The vapor barrier is exposed and is required to be concealed.
The vapor barrier forms a seal between the heated interior and the outdoors. A section in the crawl space is exposed. It's flammable, and for safety it must be covered with a flame-resistant material. It turns out, though, this problem is just the beginning. Infrared tests have shown that excess heat is escaping the building, right along the edge of the roof. Just how serious this is, no one knows for sure. The team investigates.
Up high there, Stephen.
The problems they find are worse than they realized. What to do immediately becomes a point of contention. The construction team has a plan, but it flies in the face of the original design. To reach the damaged portion of the airtight rubber seal, they want to dismantle a section of the roof. Sandy balks.
I'm not willing to move off the position that I've committed to previously with the design team, that I backed up their recommendation that the original design intent should be upheld.
I don't want to reject any
the big picture, and I don't know,
any options.
Sandy's solution is to repair the problem from the inside, but that means working through a maze of steel beams, pipes, and wires.
Huge issue.
Yes, but if it's so difficult, then it needs to be rejected collectively, and then we can go back to, I feel, the external methods.
He's come up with, I think, some pretty good ideas, but they're...
But I can't compromise. I mean, there's only so much. So far, I can compromise. This one's dicey.
The debate seems to be going nowhere, so the team heads for the roof. What they find there is disturbing. Heat loss from the leaking vapor barrier causes more than just the waste of precious fuel.
Yeah, it's been driven off by the heat of the solar.
Ice building up under the plastic sheeting could eventually cause the structural panels to separate and then fail. Repairs will require ripping off the entire length of the chamfer, the slanted edge of the structure. It's an enormous job, and not one that can be done before winter. The two teams finally reach a compromise. They agree the problem is serious, but not threatening to the safety of the crew.
Well, I know that resources in the next few weeks are definitely already overcommitted, but
Major repairs can wait until next season. But the debate over the vapor barrier leak took up a lot of time not spent on other key issues.
Okay, here we are. It's the night before.
With less than 24 hours to go, the situation looks bleak.
I'm still hearing a lot of new priority ones, and I'm not exactly
If the remaining deficiencies are not repaired, re-inspected, and approved by this time tomorrow, this supposed final season will end in serious disappointment.
Still, I guess I'd like a count now.
I get 52 from this list, and that includes the outstanding ones.
Good luck. I sincerely mean that. So let's see where we're at tomorrow.
24 hours to go, and it looks to me like if you do your math, or what I've heard today is we've got roughly 50 to 55 priority 1 items. Some of them are fairly labor intensive. Some are going to require materials on site that we're going to have to continue to find and fabricate. The effort tonight is going to be a long one.
We've been given a list of things to correct, and in the process of doing that, we found a few other things. So, yeah, it's a pretty good couple of pages.
Yeah, fix that ceiling.
The final night is a full-court press. Work continues around the clock, almost without a break. A job made just a bit easier as the sun shines here day and night.
I finished the upstairs handrails, got the threshold done, and I'm in the back doing the cove base. I just need the exterior corners.
As Hell Week finally draws to a close, the team is spent. Workers are worn out, and conditional occupancy still not granted. An entire year of work and millions of dollars hang in the balance. Success or failure depends on the events of the next 24 hours and the signed consent of one person. Hell Week has pushed the entire team to the limit and beyond.
Re-chisel, re-screw that in, put the lock wherever we want. Yeah.
Construction crews have had just 7 days to rectify nearly 100 punch list items. They built a stairwell from scratch, repaired electrical lines, mechanical systems, even the fire alarm.
Looking good.
And with just 24 hours remaining, the construction team still faced 52 priority 1 items. Each and every one must pass re-inspection today. They worked throughout the night, a final push marking the end of a long road. The South Pole Station is nearly a reality, but it's about to face one final trial.
At this point, I guess I'd like to go around the table to the members of the design team. Tim, give us a status on your priority 1 items.
Okay.
The final meeting. A year's worth of work has come down to this.
A couple of things I can.
Each inspector gives a report, a final judgment of the construction crew's work.
Those are my priority 1 comments.
Okay, thank you.
If all outstanding deficiencies have not been corrected, conditional occupancy can't be granted.
Well, Sandy.
Well, I'm honored to have this important responsibility, and it's a privilege to have been part of the design team back in the 90s, and to now be here witnessing this remarkable engineering creation come to life. It's truly amazing.
It looks as if one final all-nighter may have paid off.
I accept on behalf of the National Science Foundation and the Office of Polar Programs, Wing A4, Wing B3, Wing B4. So conditional occupancy is hereby granted. Congratulations. Okay.
The Amundsen Scott South Pole Station is open for business.
So, let's make it official, and I can declare that Hell Week is over.
This team has pulled off an amazing feat. They've built a station that will be home, office, even recreation for some 150 people. Most importantly, it will allow scientists to focus on research that may change the very way we see our planet. The 10-meter telescope is now capturing some of the most stunning images ever taken of space. IceCube is giving scientists a treasure trove of data never before available. And evidence of climate change is being monitored as never before. Even a new communications satellite has linked police to the outside world in a whole new way. For Jerry Marty, it's an incredible accomplishment.
To be part of that team is something that, for me personally, it's completing the loop on a chapter of my life that's been a dream and a goal forever and ever.
Which battery? Okay, good on you.
Smile! For BK Grant, the South Pole has been her life for more than 16 years. The opening of the new station is a crowning achievement.
It's an amazing thing. I never really imagined I'd be part of something like this in my life. And it's been the most important thing that I can think of.
And for Carlton Walker, there's no denying the difficulties he's overcome or what he's achieved.
For the last 8 years, we fought it every year to get to this point, and we did, so we're there.
The Amundsen Scott South Pole Station completes a dream begun more than a century ago. The first humans to reach this spot could never have imagined the world here today. A world dominated by a building that has pushed engineering and technology to the absolute limit. It's a stunning achievement and a landmark that will define the Antarctic for decades to come.